now on the one hand, we have our landscape of vacuum states of string theory. On the other hand, we have our bubbling multiverse. And I think bridging these two sides is something called a vacuum selection principle, or that might come in there somewhere. How is it that one vacuum state becomes connected to one of these bubbles so that we get this populated landscape?
Okay, as these bubbles form, that's first of all an extremely good question, one that I'm not sure I can give a satisfactory answer to without the blackboard and some equations and so forth. But come back to this kind of inflaton field. The picture is that there are lots of inflaton fields. When these bubbles nucleate, they nucleate with values of these fields inside them. The fields can have different values. So when they nucleate randomly, just completely randomly, they nucleate with a particular value of the fields, which means a particular value of the parameters, like the fine structure constant and so forth. This is random nucleation of bubbles, each bubble being at a different point in the landscape. It's randomness. That's where quantum mechanics comes in. Quantum mechanics tells you there will be no deterministic answer to what a particular bubble will do. It's random because of quantum mechanics. So if a bubble nucleates, there's an element of quantum mechanics which tells you there's simply a probability for it having been this kind, that kind, that kind, and not a deterministic answer of what kind it is. Does that help answer the question? Mm-hmm. Yeah, okay. I mean, it's quantum mechanics. Mm-hmm. I think somebody said, what was it? Anything in quantum mechanics, anything which is possible will certainly happen given enough time. Anything which is possible will happen given enough time. And the universe goes on for a long, long time. So if it's necessary for a particular kind of environment to occur, for us to be here, given enough time, it will happen. One of these bubbles will nucleate. It's not saying that most of them, vacuum selection is a funny word. It sounds like there's a selection principle which tells you what the vacuum should be, or a selector. No, it's exactly the opposite. There is no selection principle. There's only the randomness of quantum mechanics.